Swayam Prabha. Digital India. Educated India.
Good morning. Welcome to this ongoing online course on Engineering or Architectural Graphics Part 2, and in this course we are learning how to draw isometric drawings. In yesterday's lecture we had seen how to convert orthographic views to isometric drawing, and today we are going to continue the same. I will take some more examples. The fundamentals for drawing isometric drawings, for making isometric projections, remain the same, which we have discussed in the previous lectures, and we have seen how to convert the orthographic of any given 3D object into isometric. So, the fundamentals, the basics remain the same. What we are doing is, with the help of examples, we are trying to show how we can convert the orthographic views into isometric drawings. So, I will just continue with the same thing today, and once we have completed this, in tomorrow's lecture we will be looking at reversing this process. So, what if we have an isometric drawing which is given to us? How can we generate the orthographic views out of that? So, this is what we are going to do in tomorrow's lecture, and today we will continue with conversion of orthographic views to isometric drawing. So, this is the first object. Now, we can see, we can identify the reference planes, the parallel planes, and we will also have to decipher what this orthographic drawing projections which is given here is telling us. So, we look at these parallel planes which are going to remain parallel. So, there are 4 of these planes which we can see in the elevation. Now, in the top we can actually see that there is a square, which means that this is a square. Now, we can see these 2 hollow lines, the dotted lines here, which imply that this circle, the dark circle that we are seeing in the center, is a hollow, while this is a shaft which is again circular, because we can see the dimension given here, which is the diameter. And in the bottom we can actually see that there is a hexagon which is coming here, which is what we are seeing. So, if you project this, you can actually see that this is the line which we get, and the side of the hexagon is equal to the diameter of the circle. So, this is what we have, and which is what we will start drawing here. Now, I am going to draw from the top to the bottom, and we will draw the different faces one by one, these planes, the parallel planes. So, if we start from the top, we have this square. So, square is of 40. I will take the same units in the grid, assuming one grid to be of 10. So, this is the top square, the top reference plane, which we are taking from here in the plan. So, this is a square of 40, and we know this is where the axis is passing through. So, I am just going to draw an axis here, because everything is axial here, everything is around this axis. So, this will help us in having a proper check reference point. So, this is where this point is, which is imaginary. Now, along with this we also have this circle which is dia 20. So, we make this reference square for bringing the circle here, which is where we will get this circle. So, now what we have drawn? We have drawn this square, we have drawn this circle, that is in the plan, and in the top one we have drawn the circle and the square only on this reference plane. Now, we have another reference plane. Suppose I assume that this to be 10. So, I will make another one here, and at this level. So, if we look at it in dotted, this is the square, and this is where the circle in the bottom is going to come. Okay. So, now what we have? We have another circle at that level. Now, if you see, we can see that this dotted part will actually be revealed. So, only this dotted part will become thick, dark, and we can actually make a dotted one here because this is hollow. This will be representing the dotted lines. So, we have this, we have these lines represented by the dark lines here, the solid lines here, and another face. Now, we have to draw the shaft of this. So, say this is 50. Now, the center of this is this point, 50 down. So, this is where this circle is going to come. So, this is the face where we are going to get this. Now, I draw another reference square here, which will give us the circle in the bottom. So, this is what we have. Now, we know that this shaft is going to be a solid shaft. So, which we can join here. I will darken it later, but we can just draw it. Okay. So, this is the shaft of the cylinder. Now, this is resting on this hexagon. So, we can have another reference rectangle here. So, this is what we have. Now, the square, if it was to come, it would have come here. So, what we have here is this hexagon. So, this is the reference rectangle for the hexagon, which we have, and now you can mark the points. So, we have one here. So, this is the hexagon which we will get. We can join this. This is one of these parallel faces. Now, we also have one more face. So, we drew this one, and now we have to draw this one. So, we can just bring all these points, because this is again parallel, we can bring it down very simply by one unit, and we can join them. You could do this at the back and join them too. So, this is what we will get just by drawing the parallel planes which we have identified. These vertical edges are the ones which we see here. So, I will just darken it now, and you can see the actual object being visible. So, while you darken, you have to remember which are the visible parts of the object which is given to us. So, this is the top square which you see. This is the top circle which we see, the dark one, and this is the part of the lower one, the dotted line. This is the square top. Now, this is again going to be dotted, and this continues as a solid line, because this is the shaft which we are going to see, the visible portion of the shaft here, and the dotted one at the back. And then we darken the hexagonal base. I am not drawing the dotted line there, but this is how this object would turn out to be. So, the simple thing that we are doing is we are identifying the parallel faces, we are making the reference planes, the reference rectangles, and then fitting the objects into this. I will just draw this dotted one, so it gives us a clear idea as to what we are talking about here. So, this is what we will get. Let us take another example and understand with this. Now, what we have is a front view here, a plan and a side elevation in this side. Now, we will start doing the same thing as we did yesterday, and we will start by drawing the entire plan. We can do that, or we can also start part by part. So, what we can actually see is we can draw this part first and draw the remaining part later, or whichever way you think. I will try by drawing it in parts. So, I am considering only this part first, okay, which is what is seen from this side. If you look at this, what the side elevation is this, which is seen from this side. Okay. So, what I draw, if I have to draw the front elevation, I am just drawing this front elevation here. So, this front elevation, so I am not following the dimensions here. So, I am only taking this part because there is no line here. Then we have two solid lines here, and then we have a curved surface here, and having the same center, say we have a circle which is, okay, so say approximately here we will have this circle coming. This is what we have in the front elevation, and then we also have some dotted lines here. So, which means that there is a hollow or something which is there. Now, overlap it with the plan. So, what we see in the plan is, or maybe I can project it if I were to draw it in the back, then I could have projected, but since I do not have space, I will just make it towards the back of it. So, what we have here is, I am drawing only this part of the plan. So, we have this, and then we have this. We also have this dotted line, okay. And in the plan we can also see that we have an inclined line like this. Now, we can very clearly see that not everything is matching up here. The same elevation we can assume to be here, because this elevation could be at any level, all these lines. So, now if you look at this, we can very clearly see that this surface, this curved surface is not at the same level as this rectangular surface in the bottom. And we also see that there is a separate line. Here we can see that there is a solid line, which means that this surface is not the same as this surface. It is not a continuous surface, which is what we can see here, that we have an inclined line, which is what we can actually get when we are looking at this surface, which appears to be an inclined surface, not a flat surface here. So, what I am doing is I am taking this part of the elevation, the curved part of the elevation towards the back. So, if we can draw the same thing here, so what we will get is this. So, we just drawing this one at the back, and a straight line here. Now, this has another line which is parallel, which implies that this is a surface which is coming together like this. So, if I draw another curve here and a line like this, and this circle also goes to the back. So, if we have to see, this is where this circle will be going back. You can try to look at the parallel lines, you can look at the distances, how we are taking it back, and there will be another one at the back of it, which will be the same size. I am just drawing it in dotted because it might and might not be seen, and now we can see that it is actually not seen. So, this is a hollow. So, what we have done is we have taken this part, the front part of the elevation, like the elevation from the front plane to the back plane, and we see that the edges actually match. And this is a continuous curved surface. So, we will see it like this. Now, simultaneously if you draw the side elevation here, so what we see here is in side elevation we have this surface as a continuous surface, which is how we are getting it here, and then we have a solid line. Okay. Now, if you look at this, this solid line is matching with this line in the plan, and then this line is matching with this point. So, what we arrive at is that this surface is how these edges will be joined. Now, all our lines are fine, they are in order, and if I have to now remove, and then there is a solid line here, which is, otherwise the edges can't be joined. Okay. And in this side, here we can also see that there are two dotted lines, and in the side one we can see that there is a circle in the side view. So, we will draw a circle here, and then at the back also we would have a circle, a hollow. So, I am just drawing it in light because we do not know if we would be seeing, and we can see that with the given thickness that we have assumed, it will not be seen. Now, I will just, so what we have done is we can just check the lines, and I am deleting some of the ones, it is going to confuse you otherwise. So, I am just removing the layers which we had assumed at different levels. These are the dotted lines which we can see that these are covered by the hollow that we are assuming here. So, I am removing the dotted lines here. Then the straight lines which we originally assumed, because now this is a continuous curved surface. Again this one will go, which was at the back, the ones which we drew in the front. Okay. So, this is also the circle which we drew originally in the front elevation, but which we have now assumed to be going at the back. So, if I were to now draw the front part of it, which is going to be fully visible, we can just darken our final object. All we have to do is identify where these surfaces are coming, and here in this it is not just the knowledge of how to draw the isometric, but it is also understanding the object which is given in the drawings, orthographic drawings. You have to understand that. So, understanding that, putting together your knowledge of how to draw isometrics, you can actually draw whatever object is given to you. So, this is how we would, this is what we would get. This is the front part of it. Okay. Now, we have to draw the rest of it, the rear part. Now, since we are looking at it from this side, this is the front elevation, this is the front elevation, and this is what we see in the plan. This is how it will appear, because if you remember, this is, if I have to assume the axis here. So, if we are just assuming this is the axis, okay, and this is your VP and this is your horizontal plane. Okay. So, now we will go to look at the rest of the object. Now, look at this. So, what we have here is that we have in elevation this line which is continuing. So, now I am going to draw this part. Okay. So, from it this part, and we do not have much visible from the side elevation, from this side elevation. So, we will start by drawing the object that we have at hand. So, this is what you see here, and then we have two dotted lines here. Okay. In the front elevation, then we can also see that there is an inclined line like this. This we have already taken care of, this is what we have to take care of now. So, this is what we will see in the elevation. I have just drawn it here, we can take it at any level. Okay. Now, in the plan, what do we see? We see that there is a solid line. So, it is a distinct surface, it is not continuing at the same level. So, definitely either it is curved or it is inclined. Okay. So, this is what we see in the plan, and then we also have this curve coming. So, we can draw this in plan, and now we can also see that there is a circle which is coming. At what level we have to determine. Okay. Now, since there is a distinct line, either this is a curved surface or an incline, which very clearly we can see that this is an incline and it is this surface, it is at this level. So, at this level and this level, this is an inclined line, because in the front we can only see one line. So, it is one single incline, which is what we will do, we will just take it back. Parallel, these are all parallel lines, and now we can just join the way we did here. And sorry, 1, 2, 3 and 4. You will see the moment we join this, these are all parallel. So, all that we have done here is taken this front surface which we were assuming was here to the back, okay, and this is at this level. So, we will have a vertical going here and this one which is parallel coming back to meet here. I will remove what we drew in the front because we have already arrived at this one. Now, this is the other one, the plan that we have to take. Now, already as this is inclined and we have this line which is here, it is definitely a vertical surface where this plan cannot be, because we cannot see this line. So, this plan, this curved part of the plan is definitely here, which is what we will then draw. So, if we bring it here, this is how we are going to see this plan, this curved shape, and I am going to delete it from this level. Okay. So, I am also removing these lines because we have already arrived at this, and now we have to bring this circle down to the bottom. So, we will just bring it down, look at where the center of this circle is, locate it appropriately and then draw. Now, since this is a hollow, we will also have to arrive at where the circle in the bottom is going to be. Now, every time you might think that we already know that this is not going to be seen, but yet we have to properly determine that this is not going to be seen. So, this is what I have drawn here. So, I will remove this one because we know that this circle is not going to be there. Okay. So, this is the line that I am removing now, and why? Because this surface, we can see that this is a continuous surface which is going with the curve. So, we can actually see that this is a continuous surface, at this level it merged. So, what we will also have to do is at this level we will have to draw another part of the curved surface. So, only the front being visible. This is what we are going to be seeing finally in this object. So, I am just darkening this one. This is the rear part. This is what we would see in the plan in the front, the lower level of the surface and the hollow circle. So, if you look at, if we want to draw, we can actually draw the hollow circle at the bottom also, and the same thing we can also do here if we want to do, so that it becomes amply clear that there is a hollow here. This is what we will get, we will arrive, and you can check it again. No lines should be missing, no surfaces. So, every line has a meaning, like this one, which means that this surface is at the same level, but this one is not, which is what we see here. This is at the same level, but this is not, this is a slope. The same thing in the front, if you look at this, there is a solid line here. So, this surface is different from this surface, this is continuous, which is what we are seeing here. This is a continuous surface, but this one is not, there is an incline here. In this side we can see this is a continuous one, this is not. So, we see that this is a continuous one, but this is not. So, wherever this hollow is represented here, this circle we can see here. So, it matches this hollow, and the circle which we are seeing here is this one which we saw here. Same as with this one which we are seeing here. So, whatever we draw, all the lines make sense. The hidden lines have a meaning, the dotted lines have a meaning, the solid ones have a meaning. The only thing which we cannot understand from just one view of orthographic is that what is the depth, at what level are these planes coming and intersecting each other, which is what if we draw them together we will find out from the isometric very conveniently. So, we can see that most of the lines we have got covered here, but one thing which I have overlooked and which is a mistake here is that we have not accounted for this curve which we are seeing in the side elevation. So, this is the surface which is coming here, okay. And now what we have to see, this is a continuous surface. So, what we have to draw is, if this is the same center, we will have to draw the curve. So, this is the curve which will come taking the center back equivalent to the thickness, and we get this part. So, we will actually not have a straight edge, two edges here, it is a continuous edge which we are seeing. So, I will just remove the one, this part which was okay. So, okay, so this is not getting erased, but what you can very clearly see that this is the curve and now it makes it complete. This curve which is here is the curve that we are going to be seeing here. This line will only extend, okay, and whatever part is visible behind this curve is going to come to the front. Let us look at one more example of this one here, and we will try to draw again level by level, okay. So, what I am going to do initially is draw only the central part. So, we have this very distinct central part. So, if you understand this, forget about this part for the time being. So, what we have is we have an inverted barrel, a part of cylinder which is hollow from the center. So, this dotted line is actually this dotted line is this, and there is a solid line. So, assuming that there is a solid line, this is where it is going to be. So, what we are doing is we are just drawing this barrel here first, and then we will draw the remaining part. We will have to start because this is a combination, there are a lot of different objects which are coming together. So, that is why we can break it. The more complex it is, we will have to break it in parts, but the reference for the other one has to remain, okay. So, okay. So, what I am drawing here is the central part which is like a barrel, okay. So, okay, let us assume this to be simpler one. I am drawing the elevation here, okay. So, assuming that this is how the barrel is going to come. So, we will draw the circle here, and like this. This is what we are seeing in elevation for this one, okay. And then we know if we are drawing this elevation at this face, the other face is say somewhere here. So, I am just assuming these dimensions, you will measure when you are drawing. So, this is where the rear face of this barrel is going to come. Now, we know that this is a parallel object. So, I am just drawing it, the outer one here, okay. And we know that we will not be able to see this part. I am just drawing it thin because we will have to draw a line. Right now, we will draw it, but then we know that there is no continuous line because it is getting interrupted by this object, Okay. We can also draw the dotted part, but it is definitely not going to be seen, but there will also be a dotted line here, this one here, right, that will also be dotted. So, this is the central part which we have drawn. Now, let us look at this part. So, where is the reference? The reference is here. Okay. So, we have this reference plane here. We know that this is the point where we have the reference plane for arriving at the center of this and all of this. Now, we are also going to draw the reference for this one, but it is slightly offset at the back. So, what we are going to do is we are going to take this offset, which is this on this line. So, say this one, and we know that this is the same plane. So, this is where we are going to draw our front elevation of this part, the left part. Okay. So, what I will do? I will draw the elevation which we got. So, what I am suggesting is every time I take up this problem that we identify where the reference plane is. Okay. Then assuming that this is where the center of the circle is. So, inner one comes approximately here. Okay. So, this is the circle that I have drawn at this reference, which is the correct position. So, we are drawing a reference plane here, both in plan and in elevation. So, right now we are drawing only the elevation. Now, there is the center remains the same and we have to draw the remaining part of the circle. So, you assume what this the size of this one is going to be. So, we will arrive at the remaining part of the circle, and when it comes to the top, it continues to go straight. Okay. Now, where is it going to intersect this surface? How will we derive that? We will derive that by drawing the same circle which we have drawn here at this face, which is how we will know that where this line is going to come. So, I will draw a circle here, this part of the circle, okay, and wherever it meets this is the curved part which we are seeing here in this one. So, this is the curved part which we have arrived by drawing a circle at this face, because it is parallel. So, once we cut it parallel, we are definitely going to see the same thing. Now, we will draw the same thing, exactly the same thing at the other face which we will arrive at here. So, assuming that this was somewhere here, we will draw an exact face just like we have drawn here at the back. Okay. Not everything will be seen, so you can choose to draw it from the top. So, we can do it exactly like this. I can draw another circle here, okay, and then we can draw this parallel line. So, this line is parallel to this. So, we will get it parallel again, and then we get this flat surface, this flat part, and it is continuing. So, we will see what and where does it come. So, this is so you can arrive at the center of this one here and then draw the circle, bring it back, which is so we have to draw the reference planes at the back, the reference squares for the circle. And this is what we would get at the back of it. The same thing we will do with this circle. We will arrive at this circle at the back, join them, and we know that this is a hollow because this is a dotted line, okay, and this dotted line is for this part. So, we get all of that in place. I will now darken the front visible part, because we have already completed drawing the visible part in the front. So, the only tricky part of this one was to arrive at where this central portion is going to be. The fundamentals of course remain the same, and we will have to darken this part, because no edge can just, this is a different surface, this is a different surface. So, whenever two surfaces at different inclination or different plane come together, there will be an edge which will be joining them, which is what we will always see and also draw. Okay. The rest of the portion can be drawn in dotted, and there will be a surface which will be joining this. So, this is what we will get. We will have a hollow here which we will be seeing in dotted. Okay. Now, the rear portion of this one. Now, I am not drawing this part currently here, because we still do not know where it is going to get cut. Okay. And this is the solid part of the line, and this is the dotted part which we are going to see beneath this. Okay. This circle also will remain intact. Okay. So, now we have drawn the first part of it, the left hand side part of it. We will now draw the remaining part. Okay. Again, what we will do, we have to identify which plane it is, and again we can see that in horizontal it is the same plane which is going to continue, but where exactly? So, it is say halfway back, one half of the unit. So, this is where we will draw our elevation. Okay. So, in the plan which we see here, this is the elevation, it is reversed. So, in the plan we can see that this is where your plan is going to come. Okay, so, approximately here. Okay. So, this is where your plan is, and this is where your elevation is. So, we give it certain height, and if I were to just draw it like this, this is how your elevation is going to come. So, in the elevation it is just a rectangular thing, and it is going to come and merge with this. So, what we are going to do again is at this level, which is this level, we will again draw this circle. Okay. We will take the same circular plane at the back. So, this is how it is going to come, right, and this line when it goes and meets with this is where it will meet. Now, we do not know, now here in the plan we can very clearly see that there is a curve here, right. So, if I take it up and draw, okay, the plan here, and the same thing we will have to do here is take another curve. So, we make the reference rectangle here, and this line will continue and meet it somewhere here. Okay. So, we would know that where this one is going to end, this line. So, now we will draw the plan here. So, we will take the quadrant of the circle, the same thing here by taking the dimensions of course. Okay. And then there is a cut which is going to come somewhere here, and then we have the reference for the semicircle which is going to come here. Okay. This is what we are seeing. Now, what we have arrived at is where this line is going to come and intersect with this circular plane, which otherwise we would not know, and the same is here. And now, if you see, this line is a parallel line parallel to this. So, if you join this, ideally this should be parallel. Okay. So, this is what we will get, but going back, going behind this curve. Okay. So, we would not be seeing this meeting, but we would end it here, and this is what we will end here, because it is going behind. and then we have arrived at this one, which is this curve, which is also this axis, and this edge is represented by this dotted line. So, we have represented all of them, we will give them thickness, which is what we have done here. Okay. So, we will have to draw this curve in the plan at the lower level. The same thing if you actually take this one. So, what I am drawing sort of freehand, which appears freehand, you will have to draw using the references. So, now I will just darken the ones which are relevant. And we will try to match what we are going to be seeing here. Okay. So, I am only drawing the visible parts first and some relevant solid parts, dotted parts. Okay. And this is what we will actually be seeing, and there will be a curved portion here, which is a curved surface, which will be generated. If we were seeing it from this side, there would be a curve which will be joining this, and the same thing would happen here, that there would be a curve which would be joining this. Okay. This is what we will see. So, if I remove the reference lines and the reference planes here, you can actually figure out what this object would look like, and there will be a dotted line here and there will be a dotted line here. So, now you can see that this object is complete, all the edges are meeting and matching. So, at every given point you will see that if it is not curved, there will be 3 lines coming together. If it is curved, so there is no break, it is a continuous surface. Okay. So, this is what we will see happening when we are drawing all of these things perfectly. You can actually look at this object and clearly make out that yes, this is the object that was being discussed and it looks okay. If you are missing out on certain edges, if you are not able to connect certain dots, then you would not be seeing an object which is complete. One line which I missed is this line. So, this is the line which we were seeing here, like a dotted, sorry, this one. So, this is the line which we were seeing here. So, which is what I have just drawn, and this is the manifestation of this orthographic drawing. So, that is what we are seeing, how to convert the ortho to iso. There are several examples which you can take, and I can also go on, but I will stop here, and there are certain exercises which are going to be available to you. Try solving them on your own when you work at home, and if you have any query you can write back to us. So, in this one, the only thing which we have to see, the top part remains simple, it is clear. We know that this is one surface. So, all this is going to come at one surface, and these lines are definitely at a different plane, which is an incline, because there is a solid line. So, we can clearly see that there is an inclined surface here, which is evident here, either it should have been curved or inclined. So, we know this. Then we see that there are 2 dotted lines here and here. So, one is for this one, the other one is for this one. There is one dotted in the elevation here, which is what we will see coming in line with this. So, we know that there is a block, sort of a wedge, which has a curved hollow, an inclined surface, and the rest of the surface is actually flat, which is what we are seeing here. This is a flat surface with a little cut chisel in the bottom. So, which is what you are going to draw, and in case you find any difficulty or any problem, you can write back to us and we will solve your queries. A very similar thing is happening here, where this is a slant edge, which is what we can see here conveniently. there is a hollow cylinder which is what you can see here, and this hollow is continuous. So, this central hollow is continuous, while the outer cylinder, the solid edge, will terminate here. Okay. And then this is rest of it is like a rectangular surface, a flat cuboid, a plate sort of. So, try drawing these at home, and whatever query, whatever problem you have, you can come back to us. There is one more example, there is one more exercise for you. These will be available in the presentation, or you could stop the video, you can look at these drawings and try drawing them in isometric. So, I will stop here, and tomorrow in the last lecture of this week, we will be looking at how to convert isometric drawings into orthographic drawings. So, thank you very much for being with me here today. Bye bye and have a good day.